Welcome to Why Stuff Happens. I am Hope. Let's find out together.
Let's dive in.
This is the brief on why static electricity makes our hair stand up. You know that tiny zap you get pulling off a winter sweater or while touching a metal doorknob? Today we're uncovering the invisible transfer of electrons that actually causes those sudden household shocks and crazy flyaway hair. First, all matter contains positive protons and negative electrons. When you rub a balloon against dry hair, friction isn't creating electricity out of thin air, it's redistributing it. Think of electrons like people moving between crowded rooms to find space. The balloon basically steals your negative electrons, leaving your hair positively charged. Second, if the balloon took your electrons, why does your hair suddenly rise into the air? Well, because your individual hair strands are now left with matching positive charges, they strongly repel each other, kind of like holding matching magnetic poles that push apart. And that connects right to static shocks. When your charged body touches a conductor, like a metal doorknob, the excess charge rapidly discharges to find balance, creating that tiny spark. Finally, why is static so much worse in winter? Basically, cold, dry heating air lacks the moisture that normally acts as a lubricant to safely dissipate surface charges. But it's not all bad. E-readers actually use these exact same attractive and repulsive static forces to push microscopic charged white and dark beads around to create text on a screen. Static electricity makes your hair stand up because moving electrons leave your strands with matching charges that push away from one another. So keep that in mind the next time a balloon turns your head into a temporary science experiment.